Hello friends, welcome to my channel. In this playlist, we are going to discuss fundamentals of structural analysis. This playlist is created for absolute beginners, the students of civil engineering discipline who have just got started with structural analysis. In this series of videos, we are going to discuss basic structural analysis and the underlying concepts, the coordinate systems, supports and reactions, types of loads, and in the end we are going to take an example on shear force and bending moment diagrams. Before we go any further, let's try to understand what a structure is and what we mean by structural analysis. A structure in civil engineering context is any two-dimensional or three-dimensional configuration composed of one-dimensional elements like beams and columns, oftenly known as stick elements in generic terms, or two-dimensional elements like plates and shells, or a combination thereof. A job of a structure is to safely transmit the external loads to the supports. A structure is connected to its boundary conditions via supports. These supports offer reactions based on the restrained degrees of freedom. In the process of transmitting external loads to the supports, internal actions are developed within the structure. These internal actions are in the form of axial forces, shear forces, and bending moments. When we say structural analysis, what we mean is we try to determine the external reactions offered by the supports and the internal actions developed within the structure when it is subjected to external loads. In structure analysis, we also try to find out the deflections of a structure. These deflections are in the form of translations and rotations of the nodes of the structure. Why structural analysis? We need structural analysis as a precursor to the structural design. When we know the values of forces, we can safely design the structural elements so that they can carry the external loads safely. The materials used for the structure have permissible values of stresses. We need the values of forces beforehand so that we can give safe dimensions to the structural elements.